What if I told you that your entire life, from your first breath to your very last, which you're not even aware of yet, has already happened? All of it, completely, like a finished film someone shot and wound onto a reel long ago. Sounds like nonsense? Or like the striking of a clock, after which a minute suddenly lasts an eternity, and your whole life flashes by faster than a hummingbird's wingbeat? This brings us to the most intriguing riddle that philosophers and physicists have puzzled over for millennia. How is time actually structured, and has our entire life already passed? Before we dive into this puzzle and possibly fall asleep from the amazing discoveries, please subscribe and hit that like button, because you'll probably fall asleep later anyway. And be sure to tell us in the comments which city and time zone you're watching our lectures from. We'd love to know. And now, make yourself comfortable, close your eyes if you wish, and let's explore why our seconds, minutes, and years aren't quite what they seem. Imagine a hot, sunny day in ancient Egypt around 2560 BC. You're standing at the base of the enormous Great Pyramid of Giza, which is still rising towards the sky. Dust, sweat, the shouts of overseers, thousands of workers dragging multi-ton limestone blocks up ramps. This isn't just a construction site. It's a project for generations, for centuries. One pharaoh starts, his son continues, and his grandson might even see its completion. How did they perceive time? Not like us, you see. For the Egyptians, time wasn't an arrow flying into the future, but rather a gigantic cosmic cycle. Think of the Nile. It floods every year, bringing fertile silt, and then recedes. The sun rises and sets daily. The moon is born, waxes, and wanes. Everything repeats, eternally. It's like a giant Ferris wheel, spinning in a circle, always returning to the same point. Their calendars weren't just a count of days. They were attempts to capture the rhythm of the cosmos. 3 seasons: inundation, planting, harvest, the same cycle every year. Death and rebirth, like Osiris. For an Egyptian, the future wasn't so much an unknown path as a predetermined return of the past. The meaning of life wasn't to create something entirely new, but to preserve the established order, Ma'at, so that this endless cycle wouldn't be interrupted. So what, you might say? All ancient peoples looked at the sun and saw cyclicality. True, but the Egyptians went further. They literally lived for eternity. Mummification, those colossal tombs, the pyramids, none of it was for the future as we understand it. It was for an infinite present, for Jet, a motionless, timeless existence that awaited them after death. And Nehir, ordinary, flowing, changing time. That was for the living, for the hustle and bustle of life. And the purpose of Nehi was to get as close as possible to Jet. So, it's as if they stole the future from us. Not in the sense that it wouldn't exist, but that it had already been. It was predetermined. It would return, holding no surprises. There was no room for an unexpected turn of fate when everything was already mapped out in the grand cosmic cycle. Then came the Greeks. And this is where things get really interesting. Imagine, instead of the scorching deserts of Egypt, the shores of Hellas, bustling agoras, seething with debates about the meaning of everything. The ancient Greeks also pondered cyclicality, of course, but they began to add such shades, such nuances to this picture, that it'll make your head spin. If for the Egyptian, time was a river flowing in a single channel, for the Greeks it began to branch out, diverging into streams. They divided time into 2 astonishing concepts. Do you know what they are? The first is Chronos. This is our familiar time: seconds, minutes, hours, days, linear, measurable, like the ticking of a giant metronome. It's the highway we all travel from point A to point B, from birth to death. And the second is Kairos. This is something else entirely. Kairos isn't about how much time has passed, but what kind of time it is. It's that opportune moment, lucky instant, the right time. It's not a second, it's an opportunity. It's not just a segment of a journey, it's that very fork in the road where you must turn, otherwise you'll miss your chance. Physicists might say, so what? Those are just words. But no. These aren't just words. They're the difference between a destiny that's written to the end and a destiny you can intervene in. Remember ancient Greek myths. The Moirai, three sisters who spin the thread of a person's life. One spins, another measures, the third cuts. It would seem everything is predetermined. You're just a puppet. But then why do heroes like Odysseus fight so desperately, make choices, take decisions, and risk everything? Because there was Kairos. There were those critical points, those special moments, when your choice, your action mattered. It was in a Kairos moment that you could try to change the direction of your personal river of fate, to turn onto a different current, or at least not miss your chance. So the Greeks, on the one hand, recognized the universal Chronos, this relentless march of events that pulls everyone forward. But on the other, they introduced the idea that within this flow, there were islands, where your will, your awareness of the moment, could decide a great deal. It was as if they divided the currents of destiny. One, wide, general, inevitable. The other, narrow, personal, requiring your intervention. And this was no longer just a passive waiting for repetition. It was the first hint towards understanding that time isn't just the ticking of a clock, but something far more complex, intricate, and perhaps even open to our influence. Perhaps they knew something that we, with our digital watches, sometimes forget. July 5th, 1687. Imagine London. The air probably smelled of rain and ink. Printing had long ceased to be a novelty, but what emerged from the printing press on this day would revolutionize the world of science for centuries. Isaac Newton's Mathematical Principles of Natural Philosophy. This wasn't just a book. It was a blueprint for the entire universe. Every star, every planet, every apple falling from a tree was henceforth subject to clear, elegant laws. And do you know what was the cornerstone of this grand cosmic mechanics? Time. Newton said, time is absolute. It flows on its own, uniformly, identically for everyone and everywhere, like a gigantic, invisible metronome, beating the same rhythm in all corners of the cosmos. No matter where you are, on Earth, on Mars, or hurtling on a comet into distant reaches, time for you would be the same. Its flow depends on nothing. It's simply a backdrop, a universal ruler by which all events are measured. Like a single cosmic timer, started at the dawn of time, its readings identical for everyone. Convenient, right? Understandable, logical, a straightforward truth. That's it, physicists cried in unison for nearly 300 years. How else could it be? Echoed the philosophers. My watch shows the same time as Big Ben. What more do I need to know? Shrugged the average person. And all was well. Until he stepped onto the stage. Albert Einstein. And he said, "Oh no, it's not." Well, or something like that. Perhaps he didn't shout, but simply very quietly and thoughtfully wrote down his equations. But the effect was as if he'd yelled at the whole world and then hammered his fist on the table, making everyone look anew at what had seemed unshakable. Imagine this situation. You're on a train. An open book rests on your lap, and landscapes flash by outside the window. You're reading. Now imagine your friend is standing on the platform, watching the same train. For you, the book is stationary, but for your friend, it's speeding along with the train. Which is true. Both are right, but each from their own perspective. Newton said, "Time is the tracks the train rushes on. The tracks are always the same." Einstein replied, "What if the tracks themselves could stretch or shrink?" And that was a shock. For him, time ceased to be a separate entity. It turned out to be inextricably linked with space. Thus, the concept of space-time was born. Listen, it's like a bedsheet. Space is this sheet, and time is how events unfold on it. But if you place a heavy ball on the sheet, say a massive planet or star, it will sag, right? Space-time works the same way. Mass and energy distort it. And here's where it gets really interesting. The distortion of space-time affects the flow of time itself. Whoa, hold on a second, you might say. How's that? My time can flow differently than my neighbor's time? Precisely. For Newton, time was like a universal ruler. You buy a ruler at the store, it's 100 centimeters everywhere, period. But Einstein says, you know, that ruler can stretch a bit if you pull it quickly or place it next to a very, very heavy object. And this isn't just some philosophical chatter. This is real, experimentally confirmed science. Atomic clocks aboard GPS satellites orbiting Earth run ever so slightly faster than clocks on the surface. That's because up there, gravity is weaker and their speed is higher. If it weren't for Einstein, your navigation system would be off by tens of meters every day. Your phone would show you in the next town, not at home. So who was wrong? Nobody. Newton simply described the world we experience every day. A world where speeds are low and gravity isn't extreme. And for that world, his laws are perfect. But Einstein looked deeper. He showed that our familiar absolute time is merely a special case. Comfortable, understandable, but not complete. He showed us that time can be flexible, fluid, relative. He unchained time from the shackles of a universal metronome and cast it into a dance with speed and gravity. And do you know what's craziest? That was just the beginning. Because if time can slow down or speed up, does that mean it doesn't flow at all, as we imagine? Imagine Italy, early 17th century. Around the year 1600, night. A dark, velvety night. Galileo Galilei, a man unafraid to look through a telescope and see the truth, stands on one hill. On another, about a mile away, is his assistant. Each has a lantern with a shutter. "Open!" shouts Galileo, and the assistant opens the shutter. Light flies. "I see it," shouts Galileo, and opens his own lantern. The idea was simple: to time how long it would take light to travel there and back. Did it work? Of course not. For their primitive clocks, light was instantaneous. He couldn't measure it. And we, as humans, long believed that light was simply an incomprehensibly fast greeting from a star. We're used to, things like absolute speed. Here's a car driving at 100 kilometers an hour. You're running inside it at 5 kilometers an hour. For you, the car is stationary. For someone on the roadside, you're flying. Simple arithmetic. But with light, it's not like that. Imagine you're flying in a spaceship, hurtling at 100,000 kilometers per second. Just insane. And you switch on a flashlight. How fast, do you think, will the light from that flashlight fly away from you? You'd say, well, 100,000 plus 300,000, the speed of light, equals 400,000. But no. And this is where the real cosmic tricks begin. So then, a young man named Albert Einstein comes along and says, "Guys, what if the speed of light is a constant? No matter who measures it, no matter how fast they're moving, it will always be about 300,000 kilometers per second." Physicists were like, "What nonsense! That defies common sense. It's as if you were on a train, threw a ball forward, and for someone at the station, the ball would travel at the same speed as it would without the train. Unthinkable." But Einstein didn't bat an eye. He said, "If that's the case, then something else must change." And that's when he pulled out his joker. Time. Listen carefully. If the speed of light is the same for everyone, then for someone moving very fast, time itself must begin to slow down. Imagine you have a spaceship, and on it, a perfect clock. Tick-tock, tick-tock. But this clock is made of light. Here's a beam of light bouncing between two mirrors inside the ship. Each tick is when the beam travels from one mirror to the other. Now, imagine your ship is hurtling past Earth at immense speed. For an observer on Earth, the light in your clock has to travel not just up and down, but a zigzag path, because the ship is moving. And since the speed of light is the same for everyone, to travel this longer path, the light needs more time. And here's the miracle. For you inside the ship, the clock ticks normally. You don't notice a thing. But for the person on Earth, your clock slows down. Tick, tock, tick, tock. This isn't science fiction. It's a proven fact. In the 20th century, scientists flew atomic clocks on airplanes around the Earth. And when the planes landed, it turned out their clocks had fallen behind. By a fraction of a second, of course. But they had fallen behind. You know, it's like you're baking a cake according to a recipe, and your friends next door, using the same recipe, are baking it slower. And just as they're taking their cake out of the oven, you've already eaten yours. This is called time slowing down, or scientifically, time dilation. The faster you move, the more time slows down for you relative to those moving slower. What if you could accelerate almost to the speed of light? "Well, I'll just fly somewhere quickly and come back," you'd say. Yes, for you, weeks would pass. But for your friends on Earth, decades could go by. You'd return to Earth, and your friends from yesterday would be elderly, or their children, whom you knew as infants, would have grown up and had grandchildren of their own, and your yesterday's lunch, for someone else, would already be far in the future. Doesn't that make your brain creak a little? Time isn't just a uniform march in one direction. It's more like a river, where the current can be different for different travelers. And the fastest current, strangely enough, is stillness. The faster you try to swim, the slower the river itself flows for you. A paradox. Absolutely. Listen, if you thought we'd already peered into the strangest corners of the universe, then prepare yourself. Because now we're diving into an abyss that gives many physicists chills. Imagine October 1908, Cologne, Germany. A gathering of scientists discussing Einstein's new revolutionary theory of relativity. Hermann Minkowski, Einstein's former teacher, a brilliant mathematician who had literally fallen in love with his students' ideas, steps up to the podium, and he utters words that would forever change our understanding of reality. Henceforth, he declares, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. Boom. This wasn't just a scientific paper. It was a thunderclap. Minkowski proposed something wild that our brains refuse to accept. What if time isn't a separate current we're swimming in, but another dimension, just like height, width, and depth. 3 dimensions? Familiar. Right, left, up, down, forward, backward. And to these 3 familiar dimensions, he added a 4th, time. We don't just live in 3-dimensional space, but in 4-dimensional space-time. And here's where it gets really chilling. Imagine a giant loaf of bread. Each thin slice of that loaf is a separate moment in time. Here's the slice, your morning. Here's the slice, your first love. Here's the slice, your today. And here's your future. They all already exist. All these slices are already cut and assembled into one massive block universe. Or, if it's easier to grasp, imagine our entire life is a film already shot and edited. From your first cry in the delivery room to your very last breath. All the frames, all the moments, they already exist. They coexist simultaneously on the universe's giant film reel. We simply watch these frames sequentially, frame by frame, when in reality, the entire film, your whole movie, from beginning to end, is already there in a cosmic box. Listen, I know your jaw is probably on the floor right now. You're like, hold on, wait a minute. How is that possible? Does that mean my future doesn't exist as potential options? It's already out there somewhere? Exactly. If you accept this idea of a block universe or a static cosmos, then everything that was, everything that is, and everything that will be are simply different points on a 4-dimensional map. There is no past. There is no future. There is only a fixed, unchanging space-time continuum. And your now is just a tiny point that you currently experience as the present, when in reality it exists just as much as the day you were born, or the day you retire. Of course, someone will immediately say, but what about Einstein, who spoke of time dilation? If everything already exists, then what's slowing down? Well, my friends, even Einstein himself, though not immediately, accepted Minkowski's idea. He understood that his equations indeed describe a world where space and time merge into one. And time dilation, which we discussed earlier, is simply your unique path across this 4-dimensional map when you move at a certain speed. For each observer, their own trajectory, their own route through this cosmic block. It's as if you're driving a car across a massive, intricate map where all roads, all houses, all cities already exist. You're simply moving along them. Every second is another millimeter of your journey on this map. And what appears to be the future is simply sections of the map you haven't yet reached. And this concept, believe me, isn't just a philosophical whim. It's a consequence of our most accurate scientific theories. Scary? Perhaps. Amazing? Without a doubt. Because it means your first kiss, your graduation, your last cup of coffee, all of it won't just happen, it already exists. An eternal present, stretched across all 4 dimensions. Welcome to a world where time is just another direction. And you're just a static, yet incredibly intricate pattern on the fabric of the universe. 1824. Paris, the heart of the Industrial Revolution. A young French engineer, Sadi Carnot, poring over blueprints for steam engines, was trying to understand how to make them more efficient. He was studying how heat transforms into work. And in that moment, watching smoke billow from chimneys, listening to the pistons churn, he, unknowingly, glimpsed the very essence of the arrow of time. He realized that heat always flows from hot to cold, that you can't simply process all energy without loss. That irreversibility isn't just an engineering problem, but a fundamental law of nature. And this was just the first innocent glance at the universe's relentless conductor. Remember how we talked about your entire life already being recorded on the universe's giant film reel? That past, present, and future exist simultaneously, like static frames. Sounds creepy, right? But if that's the case, then a very inconvenient question arises. Why do we see a cup fall and shatter, but never, hear that? Never, see its fragments reassemble into a whole? Why doesn't an infant transform back into an embryo? Why don't stars collapse back into gas clouds? What invisible engine pulls us forward, and only forward, giving no chance of rewinding? Physicists puzzled over this for a long time, and the answer came from an unexpected place, from the world of heat and energy. The name of this answer is entropy. Sounds clever, right? But in reality, it's simply a measure of disorder, of chaos. Imagine your room. If you don't clean it, what happens? That's right, it doesn't get cleaner by itself, it gets messier. That's entropy in action. A system always tends towards its most probable state, and the most probable state for most systems is chaos. Here's your cup. Whole. That's one very specific, very ordered state. How many ways can it be whole? One. And how many ways can it be broken into 100,000 fragments? An infinite number, scattered across the floor this way, that way, at different angles. When the cup falls, it simply transitions from one improbable, ordered state into one of millions of highly probable disordered states. And there's no magical force that would make the fragments spontaneously jump up, reglue themselves, and return to the table. So what, you might say? Things just break. What's the drama? The drama is that this seemingly simple tendency of the universe towards disorder, that's the very arrow of time that pulls us only forward. This is the second law of thermodynamics. It states, the entropy of a closed system never decreases. It either remains unchanged, if nothing at all is happening, which is extremely rare, or it increases. Always. From a hot tea cooling down to your memories fading over time. Everything that happens in our universe, from the birth of stars to your very breath, is a process of increasing entropy. And this is where the secret to time's one-way flow lies. We perceive time as moving from past to future precisely because all the processes we observe proceed in the direction of increasing disorder. The past is a more ordered state. The future is a less ordered one. Think about it. You remember making breakfast, a state of order, ingredients separate, but you don't remember crumbs spontaneously reassembling into a bun, a state where disorder decreased. Time isn't just the ticking of a clock. It's a direction set by chaos. Irreversibility, that's its name. On a cosmic scale, this means the universe is also moving towards its maximum disorder, towards what's called heat death, a state where all energy is uniformly distributed. There will be no hot, no cold, nothing interesting will happen. Just uniform, dull, infinite chaos. And it's this overarching tendency, from the Big Bang to heat death, that creates our arrow of time. Not because there's some invisible hand pushing us forward, but because it's simply statistically improbable to move backward. Imagine you're rolling dice. 1 6 comes up. Probable. 2 6s. Also possible, but what if you have 1 billion dice and they all land on 6s? That's almost impossible. And to return to such an ordered state without external intervention is infinitesimally improbable. So the next time you look at a broken cup, know this. You're not just witnessing an accident. You're observing a fundamental law that not only dictates why that cup won't reassemble itself, but also why you can't go back to the past, and why our entire universe moves in only one direction. Listen, we've just been talking about time as a colossal cosmic blockbuster, where all the frames are already shot, from beginning to end. You'd think it couldn't get any stranger, right? Your life is a movie someone has already watched. You've made peace with that idea, perhaps with a slightly creepy feeling. But now, imagine a new character steps onto the stage, declaring, "What if this movie isn't fully edited yet? What if we, the audience, can influence what has already been shown?" Welcome to the world of quantum mechanics, where logic takes an unpaid leave of absence and common sense waves goodbye as it retires. The hook. Imagine Brussels, October 1927. Rainy. The air carries not only the smell of coffee and fresh newspapers, but something electric, revolutionary. The Fifth Solvay Conference. In a small yet immensely prestigious hall, gathered the cream of the world's scientific community. Einstein, Bohr, Planck, Schrödinger, Heisenberg, Dirac. Each a living legend, a titan of thought. And among them, just one woman, the one and only two-time Nobel laureate, Marie Curie. And it was there, amidst the cigar smoke and heated debates, that the foundations were laid for something that would blow the mind of anyone daring to look. Albert Einstein, accustomed to a world where all cause and effect relationships were ironclad, where objects existed independently of our observation, was, to put it mildly, furious. He couldn't accept this new physics where particles could be in several places at once, where they behaved like ghosts until you looked at them. He famously said, "I am convinced that God does not play dice." And Niels Bohr, his chief opponent in these debates, calmly replied, "Albert, stop telling God what to do." This wasn't just a scientific discussion. It was a philosophical duel about the nature of reality. Look, in our ordinary world, if you flip a coin, it's already headed for heads or tails. We just don't know which until it lands. In the quantum world, while the coin is in the air, it's simultaneously both heads and tails. It's both, until you slap it into your palm and force it to choose one side. This is called superposition. A particle can be here and there at the same time, spin in both directions, exist in all possible states until you look at it. And this is where the craziest part begins. The observer effect. Our very observation, measurement, or gaze forces the particle to choose one of its states. It's as if it decides what to be only when we ask it. Hold on, a skeptic might say. Are you serious? My lamp is on right now because I'm looking at it? And if I turn away, it stops being a lamp? No, of course not. Not exactly. We're talking about the micro world, about particles so tiny that our notions of reality simply crumble into dust there. But the very idea that the act of observation influences the very essence of what's being observed, that reality isn't fully fixed without us, that's already a gut punch. Let's go further. Einstein, remember, spoke of spooky action at a distance? He was referring to quantum entanglement. Imagine two pairs of gloves. You put one left glove in one box, one right glove in another, and give both boxes to different people who fly off to opposite ends of the universe. Until neither of them opens their box, neither has any idea which glove is inside. But as soon as one opens their box and sees, say, the left glove, at that very instant, without any delay, the other person, even on the other side of the galaxy, immediately knows that they have the right glove in their box. Information transmitted instantly, faster than light. Einstein was horrified. This contradicted his own theory of relativity. Or even more frighteningly, these gloves knew from the start what they were supposed to be, and their fate was predetermined. But quantum mechanics says, no, they didn't know. They were both gloves simultaneously until the act of measurement occurred. And now imagine the craziest thing, the so-called delayed choice experiment. It's like a game of tag, but the rules keep changing. Imagine you have a light source that sends out photons. These photons enter a special setup where they can take two different paths. Classical physics would say the photon either went path A or path B, but quantum physics, it went down both paths simultaneously. Hello, superposition, like a wave. But here's what's astonishing. We can later, after the photon has already traveled its paths and seemingly decided what it was, a wave or a particle, only then decide how we're going to measure it. Will we try to see which path it took, in which case it must have been a particle? Or will we view it as a wave that interferes with itself? And what happens? The choice made in the Wanambakun, prison onba, determines how the photon behaved in the Ba1 past. It retroactively becomes either a wave or a particle, depending on how we decided to look at it now. Just think about that. This isn't just something influencing the past. It looks as though our current decision changes the very nature of what has already happened. As if you watched a movie yesterday, then today decided it was a comedy, and yesterday's movie becomes a comedy. Physicists are like, what the hell? This doesn't mean you can change what you ate for breakfast yesterday. Don't expect your ex-girlfriend to suddenly remember you were happy just because you look at her. But it does mean that on a fundamental level, on the level of which everything is made, including you and me and time, the past isn't always such a fixed, unchanging picture until we observe it. It can be fluid, undefined, until the act of observation forces it to freeze into one of the possible realities. So much for the block universe, where all the frames are already shot. It turns out, even in this movie, there can be different versions, and the final edit depends on us and on how we look at reality. Creepy or fascinating, that's for you to decide. Imagine a hot summer day in Princeton, 1935. The air is muggy, windows are wide open, but even a slight breeze offers no escape from the oppressive heat. Albert Einstein sits at a desk strewn with scribbled papers. He's not just solving equations, he's playing with the fabric of reality itself. Beside him, his colleague, Nathan Rosen, also frowns, sketching something. And then they look at each other, and Einstein thoughtfully muses. What if space-time isn't just a flat highway we're traveling on? What if it has shortcuts? Shortcuts, literally. They didn't call them wormholes yet, but essentially that's what they were talking about. These guys, listen, they weren't just geniuses, they were artists of mathematics. Skeptic in the audience. Ha! Shortcuts! That's just cheap sci-fi. But wait, don't rush. Imagine an apple. You want to get from one side to the other. How? Walk across its surface, right? Long, tedious. But what if you could just poke a hole straight through it? That's what a wormhole is. A tunnel connecting two distant points in space-time. Sounds cool, right? Zip through a hole and you're at the other end of the galaxy. But what if this tunnel doesn't just shorten the journey through space, but also through time? Now things get really interesting and a little creepy. If such a thing is possible, then gravity, that great distorter of reality, isn't just capable of slowing down clocks, as we discussed last time. It could create a loop. Imagine you're driving on a racetrack. You start, complete a lap, and cross the finish line. Normal stuff. But now, imagine you could bend that track so cleverly that after driving a lap, you end up at the finish line before you even started. This is what physicists call a closed time-like curve, or CTC for short. It's a path in space-time that allows you to return to your starting point not just in space, but also in the past. Do you know how that sounds to an ordinary person? Like the ravings of a madman. Imaginary physicists rubbing their temples. Mathematically possible. But that but is as massive as a black hole, my friend. For such a wormhole not to collapse and turn into a deadly trap, it needs something special. Something that violates all our usual notions of matter. What's needed is so-called exotic matter, not the kind you find in your fridge or on store shelves. This is matter with negative energy density. Imagine trying to hold a door open, but it's not just trying to close. It's actively trying to swing open outward, and it's sapping energy from you while doing so. Absurd, right? That's why physicists scratch their heads. That's just a mathematical trick, someone might say. Perhaps. Or perhaps it's simply something we haven't discovered yet. Remember how electricity or radio waves seemed like magic centuries ago? So is there a way out of the temporal dead end? Many scientists, not science fiction writers, but serious, world-renowned physicists, believe the answer is yes. That our understanding of time is so limited that we simply don't see all the doors, all these wormholes and time loops that might permeate the fabric of the cosmos. They seriously discuss how black holes might not just be one-way streets to nowhere, but also bridges. About wormholes that shorten vast distances. And yes, about the possibility of creating a time machine, if not for humans, then at least for individual particles. Imagine the entire universe is a huge sheet of paper, inscribed with your life. Now we take that sheet, crumple it up, and 2 points that were so far apart now lie next to each other. Theoretically, this is possible. And this isn't just a mind game. Behind it are highly complex equations that show such things could exist within the framework of our current physical theory, general relativity. So, do you still think the past is unchangeable? That there are no loopholes, no secret paths? Perhaps our familiar linear arrow of time is simply that flat highway we're used to traveling on, completely oblivious to all these shortcuts that Einstein and Rosen whispered about in Princeton under the buzz of summer flies. And if that's the case, the question isn't if time travel is possible, but when we'll learn to use it. And of course, what will happen when we do. Imagine Rome, 44 BC, the Ides of March. The morning is foggy, presaging something ominous. The great Julius Caesar is already dressing, preparing to go to the Senate. He had slept poorly, and his wife Calpurnia literally begged him not to go. She'd had nightmares. And that soothsayer Sporina, remember him? He told Caesar directly, "Beware the Ides of March." Caesar could have stayed home, could have listened, could have ordered his guard to accompany him in a tight formation. But he goes. He dismisses the advice, the omens, his own intuition. He feels like the master of his destiny, not its hostage. And what was the outcome? 23 dagger blows. So listen. If our universe is a vast, unmoving block of time where past, present, and future exist simultaneously like pages of one great book, then what about Caesar's choice? His final step towards the Senate? Was it his choice? Or was his fate already written in that very book before he was even born? And most importantly, what does this mean for your choices? Remember, we talked about the block universe, where your entire life, from your first breath to your last exhale, is already laid out, like frames on a giant film reel. Imagine that all events, all decisions, all your "I wanted it that way" moments are already there, fixed for eternity. So what about our free will? "Oh, come on, what nonsense," you'd say. "Am I a puppet? I decide what t-shirt to wear today, what to eat for breakfast, where to go to work. I choose." And that's a perfectly natural reaction. We feel we control our lives. We make decisions, we regret them, we're proud of them. We act. But what if this feeling is just a beautiful illusion? Imagine a river. It flows, it churns, it rushes forward. It seems like a dynamic, constantly changing current, right? But if you look at it from a very high altitude, you see the entire river at once. Its source, its channel, every bend, every waterfall, and the place where it meets the sea. Its entire history and future are laid out before you, simultaneously. It's the same with us. We drift along this river of time, and from our perspective, it's continuous motion and constant choice. We only see the section we're currently in. But for an external, hypothetical observer, for the block of time itself, your entire life is already a finished pattern, a route already laid out. Every choice you make isn't the creation of a new path, but rather the realization of an already existing turn on a map that has always been there. "But that's insane," your inner skeptic will erupt. "Does that mean if I decide to raise my right hand right now, it's not my choice? It's just something that was already written in this cosmic book?" Here lies the deepest mystery. The physics of the block of time doesn't say that some external force makes you raise your hand. It says that the moment you decide to raise your hand and the hand itself rising into the air are two parts of the same, already existing event in four-dimensional space-time. Your will, your choice, is part of this event. You are not deprived of free will in the sense that someone else is making decisions for you. No. Your decisions, your desires, your personality, these are the very ink with which your life's line is written in this block. It's like writing a novel. Let's say you've already written the entire book, from beginning to end. The characters make choices, suffer, rejoice, make decisions. Their fates are written, but you wrote them through their choices. And so are we. We are those very writers who, at every moment, reveal the next frame, which, strangely enough, was already part of the larger picture. Imagine you're watching a movie. A character in it makes a choice. You, the viewer, know what he'll choose because the movie is already shot. All his decisions are fixed on film. But for the character himself, in the moment he stands before the choice, it's his most genuine, thrilling, unpredictable decision. We are both the characters and part of the already filmed movie simultaneously. This doesn't mean fatalism in the usual sense, that what will be and nothing can be changed. On the contrary, it means that your choice, which feels so momentary and spontaneous, is a fundamental part of the universe's structure. It is, it always was, and it always will be. This changes everything. You're not just moving from one moment to another, you are a part of this eternal, unmoving mosaic. Your choice isn't just a point on a line. It's that very line, that very curve, that makes your path unique. So when you choose what to think about this right now, you're not creating something out of nothing. You're simply becoming aware of the part of the great book that's now unfolding before your inner eye. And your free will? It doesn't disappear. It simply takes on an entirely new, incredible, truly cosmic scale. It becomes part of the very fabric of reality. And that, believe me, is more powerful than any Roman conspiracy. Imagine the 2nd century AD. Somewhere on the fringes of the Roman Empire, under a starry sky, a campfire crackles. The emperor, ruler of the world, Marcus Aurelius, not in his luxurious palace, but in a humble tent, writes his famous Meditations. He, the greatest Stoic, faced death, betrayal, and the burden of power daily. More than anyone, he understood, there are things beyond our control. Fate, the Stoic said, is already charted. Everything unfolds as it should. But what does that change? He seems to ask us across the centuries. He doesn't say, well, since everything is predetermined, I'll just sit back and wait for the end. No, he writes, waste no more time arguing about what a good man should be. Be one, for you deny yourself the opportunity to do something else. We've traveled a vast distance, from ancient myths to quantum paradoxes. We've come face to face with an idea that makes your hair stand on end. If the block universe concept is true, if all moments, your birth, your first kiss, your breakfast today, and your last breath, exist simultaneously, like static frames on a giant cosmic film reel, then, what then? Does that mean our entire life has already happened? Your future is someone else's past. Your now is just one of an infinite number of frames. So what now? Someone might skeptically exclaim. Does that mean everything is meaningless? Can we just give up and drift with the current, since the outcome is already predetermined? But no. Here lies one of the most astonishing paradoxes of our perception. Imagine you're sitting in a movie theater. Before you is a film that's already been shot, edited. It has a beginning, a middle, and an end. Every event in it is fixed. The protagonist has already lost or won. The movie is over, right? But you, the viewer, you haven't seen it yet. For you, every frame is a new discovery. Every emotion is real. Every plot twist is a surprise. And you, sitting in that seat, experience this film. That's the trick. Yes, perhaps for a hypothetical observer outside of time, our entire life is simply a data set where past, present, and future merge into one. But for us, trapped within this film reel, experiencing each moment in strict sequence, everything is different. We are the main characters of this movie. We are actors who play our roles with full dedication. And most importantly, we experience every moment. Joy, pain, love, seeking. This doesn't negate your choices. Even if your choice is already recorded in the great book of existence, the process of choosing, the very agony and joy of making a decision, they are absolutely real for you. They shape your experience. They make you who you are. It's like rereading a favorite book. You know the plot, but each time you immerse yourself completely, finding new nuances, re-experiencing the emotions. Think about this. If every second of your life already exists, does that make it less valuable? On the contrary, it makes every now unique and irreplaceable. Not just an ephemeral moment that vanishes into oblivion, but a fixed point in the great continuum, a point that will always be there. Your smile, your laughter, your tears, your decisions, they don't disappear. They exist. And this isn't a reason for fatalism, it's a reason for mindfulness. If every moment you live is part of an eternal structure, then perhaps it's worth living it so that it is a worthy part of that structure. So that this frame is vibrant, rich, authentic. We are used to thinking of time as a river that carries us away. But what if we're not being swept along by it, but are simply in it? And all points on this river, from its source to its mouth, already exist, then every sip of water you take, every wave you feel, every landscape that passes by takes on incredible value. Because this is your now. And it's not emptiness, it's eternity. This isn't a story about resigning yourself to predetermined fate. It's a story about rethinking the very concept of life, about how even if your entire story is already written, it doesn't strip it of meaning. On the contrary, it gives it weight, depth, an almost sacred significance. Your life, your moments, they aren't just fleeting shadows. They are part of a grand, eternal tapestry. So go ahead, live, boldly, consciously, every moment, because it's yours, and it's forever.